Hello everyone, I am Divya from BSc Chemistry Honors second year. Today I am going to giving a presentation on physical chemistry. My topic is distribution law. The introduction is this law was given by the Ernest Hermann Walter is in 1891. He was a German chemist known for this work in thermodynamics, physical chemistry, electrochemistry and solid state physics. His formulation of the Nernst heat theorem helped to have the third law of thermodynamics, for which we won the 1920 Nobel Prize in Chemistry. What is distribution law? Now we will discuss about the distribution law. Distribution law क्या होता है? When a solute is taken up with two immiscible liquid, in both of which the solute is insoluble, the solute distributes itself between the two liquids in such a way that the ratio its concentration in two liquid phases is constant. A given temperature provided the molecular state of the distributed solute in same of the both phases. Now we will discuss about the immiscible liquids. Immiscible liquids क्या होते हैं? Those liquids which do not dissolve with each other, जो एक दूसरे के साथ डिजोल्व नहीं होते हैं, जैसे कि वाटर और ईथर. नोट दिस लॉ इज ऑल्सो नोन एज नर्नस्ट डिस्ट्रीब्यूशन लॉ. इस लॉ का दूसरा नाम नर्नस्ट डिस्ट्रीब्यूशन लॉ भी है. नर्नस्ट पार्शियल लॉ, डिस्ट्रीब्यूशन लॉ और सिंपली पार्शियल लॉ. Now the explanation of the distribution law. The explanation of distribution law is if a solute X distribute itself between two immiscible solvent A and B at constant temperature and X is in the same molecular condition in both the solvent, then the concentration of X in A upon concentration of X is in B is equals to K B. K note. If C1 denotes the concentration of the solute in solvent A and C2 in the concentration in solvent B, Nernst distribution law can be expressed C1 upon C2 is equals to Kd. In equation 1 or 2, Kd or simplify K is the constant distribution coefficient or partition coefficient or distribution ratio. This is the equilibrium law when the distribution of solute X has reached dynamic equilibrium. The rate R1 at which the molecules of X pass through solvent A to B is proportional to its concentration C1 in A. The rate R2 at which molecules of X pass from solvent B to A is proportional to its concentration C2 in B. Also at equilibrium, the rate of migration of solute from one solvent to other is equal as shown. Thus we have solvent A upon solvent P, C1, C2. Now we will discuss about this diagram which is given. In this there are three beakers which is present, in which accumulation of concentration will be held. At equilibrium, the number of molecules of X passing from solvent A into B is proportional to the concentration of A and vice versa. Also, the rate of migration of solute molecules from A to B and B to A is equal. So it can be written as R1 directly proportional to C1 and R1 is equals to K1 into C1, where K1 is a constant. R1 directly proportional to C1 and now again R2 directly proportional to C2, where R2 is equals to K2 into C2, where K2 is also a constant. Since at equilibrium R1 is equals to R2, K1 into C1 is equals to K2 into C2. C1 upon C2 is equals to K2 upon K1 is equals to Kd. This is our equation 3. Equation 3 is the Nernst distribution law of equation. Since K1 and K2 are constant at the same temperature, our distribution coefficient Kd is also a constant if temperature is fixed. Application of distribution law. There are numerous application. Now अब हम application पढ़ेंगे. Applications के बारे में जानेंगे डिस्ट्रीब्यूशन लॉ की, जो कि बेस्ड है equation number 3, which is C1 upon C2 is equals to K2 upon K1 is equals to KD. इसकी एप्लीकेशंस हैं सॉल्वेंट एक्सट्रैक्शन, पार्शियल क्रोमेटोग्राफी, डीसिल्वरेशन ऑफ लेड, पार्क्स प्रोसेस भी कहते हैं जिसे हम, confirmatory test for bromide and iodide, determination of association, determination of dissociation, determination of solubility, the degree of hydrolysis of substances. Now we will discuss about the solvent extraction. First application. This is the process used for separation of organic substance from aqueous solutions. The aqueous solution shaken with the immiscible organic solvent such as ether or benzene in a respiratory funnel. The distribution into being in a favor of ether, most of the organic substance passes into the ether layer. The distribution into being a favor of ether, most of the organic substance passes into the ether layer. The ethereal layer separated and ether distilled off. Organic substance is left behind. Second, partial chromatography. A paste of the mixture is applied at the top of the column of silica soaked in water. Another immiscible solvent, hexane, is allowed to flow down the column. Each component of the mixture is partitioned between the stationary liquid phase, which is water, and the mobile liquid phase, which is hexane. The various components of the mixture are extracted by the hexane in order of the distribution coefficients. Desilveration of lead या Parks process, when molten zinc is added to molten lead containing silver, zinc and lead from the immiscible layer, and silver is distributed between them. Since the distribution ratio is about 300 in favor of zinc and 800 degrees Celsius of silver phases into the zinc layer. On cooling, the zinc layer, an alloy of silver and zinc, separates. The zinc alloy is distilled in a retort when zinc passes over, leaving silver behind. The lead layer still contains extracted silver. This is treated with a fresh quantity of molten zinc to recover most of the silver. Now the fourth is confirmatory test for bromide and iodide. The salt solution is treated with chlorine water. Small quantity of bromine or iodide is thus liberated. The solution is then shaken with chloroform. On standing, chloroform forms the lower layer. The free bromine or iodine become more soluble in chloroform, concentrated into the lower layer, making it red for bromine and violet for iodide. Determination of association. Fifth, when a substance is associated or polymerized in solvent A and exists as a simple molecule in solvent B, the distribution law is modified as N under root Ca upon Cb is equals to K. Where is the N? N is the number of molecules which combine to form associate molecules. Now the sixth point is determination of dissociation. Suppose a substance X is dissociated in aqueous layer and exists as a simple molecule in ether. If X is the degree of dissociation or ionization, the distribution law is modified as C1 upon C2 into 1 minus X is equals to K, where C1 is the concentration of X in benzene and C2 is the concentration of X in aqueous layer. The value of X can be determined by conductivity measurements, while C1 and C2 are found experimentally. Thus, the value of K can be calculated. Using this value K, the value of X for any concentration of can be determined. Determination of solubility. Suppose the solubility of iodine in benzene is to be determined. Iodine is shaken with water and benzene. A equilibrium concentration of iodine in benzene Cb and water is Cw are found experimentally, and the value of distribution coefficient calculated Cb upon Cw is equals to Kd, Sb upon Sw is equals to Kd. where Cb is solubility in benzene and Sw is solubility in water. Now the eighth point is the degree of hydrolysis of substances. The hydrolysis of aniline, alene which is NH3, hydrochloride HCl in water H2O, can be followed by the distribution with the hydrochloride between water and benzene. Thus, for this reaction, aniline hydrochloride salt plus NH4Cl plus water H2O, aniline base hydrochloride acid. Thus, KH is equals to base into acid upon salt into water. By applying the principle of equilibrium, it can be shown as KH is equals to C12 into 1 plus Vk bracket close upon C2 minus C1 into 1 plus Vk, where C1 is the concentration of the base in aqueous layer. C1 and C2 are expressed in mole per liter. C2 is the original concentration of the salt, K the distribution coefficient, and V is the volume of benzene in liters added to the 1 liter of water. Now the limitation of distribution law: constant temperature, same molecular state, equilibrium concentration, dilute solution, non-miscibility of solvents. Constant temperature: the temperature is kept constant throughout the experiment. Some molar state: the molar state of the solvent is the same in two solvent. The law does not hold if there is association or dissociation of solute in one of the solvent. Equilibrium concentration: the concentration of the solute are noted after the equilibrium has been established. Dilution solution: the concentration of the solute in two solvents is low. The law does not hold when the concentration are high. Non-miscibility of solvents: the two solvents are non-immiscible or only slightly soluble in each other. The extent of mutual solubility of the solvent remain unaltered by the addition of solute to them. Contrast and comparison between the separation through separation funnel and fractional distillation. Separation through separation funnel, separation through fractional distillation. Separation funnel. A separating funnel is used to separate immiscible liquids. Liquid do not mix with each other are said to be immiscible. Two immiscible liquids, such as oil and water, can be separated by the separating funnel. Example: ether extraction is the common example of separation through separating funnel. Now the fractional distillation. Fractional distillation is a process by which compound a chemical mixture are separated into different parts or fractions according to their different boiling points. Example: fractional distillation of crude oil is common example of separation through fractional distillation. Now the principle of separating funnel. The principle behind separating funnel is that immiscible liquids separate out in layers depending upon their densities, whose part is stopper, body, stopcock, drain tip, stain. The principle of fractional distillation is the principle of fractional distillation is that different liquids boil at different temperature. So when the mixture of immiscible liquid is heated, the liquid with low boiling point boils and turns into vapors. And the parts are thermometer, condenser, collecting flask, Bunsen burner, stove heater, boiling flask, and stand. Now the both the diagram are given for both of these. This is the diagram for funnel and this is the diagram for fractional distillation. Now the application for the funnel is to separating mixture of oil and water. In the extraction of iron from its ore, the lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. And the third application is in the extraction of the iron from its ore, the lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. Now the application for the fractional distillation. The fractional distillation is used for purification of water as well as separating acetone and water. Now the second application is the fractional distillation is used in several industries like oil refineries and the chemical plants, mainly for purification and separation of many organic compounds. Third, fractional distillation is also used for the separation of liquefied air. Components like liquid nitrogen and oxygen as well as the concentrated argon are obtained. The fourth, distillation is used in production of purity silicon and chlorosyls, and the silicon is widely used in semiconductors. The advantages are good separation is achieved, running cost is low, easy to handle and apparatus equally used in the lab as well as industries. Disadvantages for the funnel is provide good separation for only small fraction of mixtures. Operation process is timing consuming. The largest risk when using a separating funnel is that of the pressure buildup. Now the advantages and disadvantages for the fractional distillation is, now the advantages are better separation of liquids, good at purification, liquid containing many different components equally used in the lab as well as in the industries. And the disadvantages are this is slower process and it takes very much time and requires more energy and more complicated and expensive. Thank you.